In the last video, we looked at the magnetic field produced by a straight current carrying conductor, such as a straight copper wire. Now, how will the magnetic field generated by a loop of wire look like? Assume that the current is flowing in the wire in this direction. So it is entering the wire from here, flowing across the loop and exiting from here. Can we use the right-hand rule here to find the direction of the magnetic field? Yes, we can. In any region of the wire, we can use the right-hand rule to find out the direction of the magnetic field. The thumb is pointing in the direction of the current and the fingers are curled in the direction of the magnetic field. So this is how the field lines across the loop of wire look like. Here too, we can draw many circles concentric to these ones in space. However, as this is looking quite cramped and unclear, we won't draw them. Now look at this magnetic field by a loop of wire and compare it with the magnetic field by a straight wire. We will assume that both the wires have the same amount of electric current flowing through them. Just like straight wire, here as well, the strength of the magnetic field decreases as we go away from the wire on the outside. But what about the magnetic field inside the loop? Inside the loop, the magnetic field lines of all the regions of the wire come together. Yes, here the magnetic fields interact with one another inside the loop. So what does it do? Because of this, there is a strong magnetic field inside the loop, especially at the center. So we can say that compared to the straight wire, the looped wire will generate a stronger magnetic field, assuming that the same current is flowing through both. Wait, it gets more interesting. This was just one loop. We can form many loops from a wire, one over the other like this. This is called a coil of wire. Many loops together form a coil. Suppose the current is entering the coil from here, flowing around the coil and leaving from here. Each individual loop will result in a magnetic field inside, and the resultant magnetic field will be much stronger than that in a single loop. Can you think how the field lines will look like in a coil? Since all the magnetic fields add up, the resultant magnetic field will look something like this. Does this field look similar to the field in a bar magnet? Yes, in fact, this is a magnet in itself. If we wrap this wire around an iron object, like say an iron nail, then the magnetic field will be even stronger inside the loop. Do you know what this is termed as? This is an electromagnet, as it's a magnet that results from electricity flowing through a conductor. Do you know what's happening here? Have you heard of the word magnetization before? Yes, here an iron nail is magnetized. It's kept under the magnetic field of this wire and hence it becomes a temporary magnet. In the past, we have discussed the two ways to magnetize any iron object such as an iron nail. One way is to get the ferromagnetic material in an external magnetic field, and the other is through rubbing it with a magnet in one direction. What we saw in this video is the third process of magnetizing any ferromagnetic object. What's the process? Yes, by wrapping a copper wire around it and passing an electric current through the wire. We will see one last thing before ending the video. Now, when the current flows in a straight wire, the wire becomes a magnet or an electromagnet. Now look at these two cases. This is one loop and this is a coil of multiple loops. Now this loop as well as the coil is an electromagnet. All three here are electromagnets. Assume that the same amount of electric current is flowing in each case. So which is the strongest magnet among the three? What do you think? Yes, this one is the stronger electromagnet compared to the other two. Because we know that inside the loop of a wire, a stronger magnetic field exists. And if there are more number of loops, the strength of the field will also increase. And one last thing here. The presence of any iron object inside boosts the strength of the field even more. There are lots of applications of electromagnets in real life. We will discuss one of them in detail in our next video.